Hi everyone, welcome back to the Clear Show. I'm Ariel, evangelist for ClearML, and it's been a while. We begin our code examples portion of the do-it-yourself model store arc. But first, a small recap. So in ClearML, we have this tiered structure where we have this open source MLOps engine that you can either use ClearML apps for or build your own. And we've done the feature store, and now we're doing the model store. What's a model store? A good example to what a model store should be is from Neil Athia's model store package. It's basically a very simple interface between your training code, your model metadata, and your models as they are stored on any bucket of your choosing. We've done a comparison between this model store package, which is like the minimal viable solution that you'd want to explore. It's the least opinionated one, and in ClearML we are, of course, very opinionated, but in terms of where and what custom data to add along with your model, we are completely clear. So this comes in this part of the table. And today we're going to show how to wrap the metadata with the model to make some sort of model registry, and actual reusing of the models and serving them will come in a later part. Now, so first thing first, I've said a few times in the past that ClearML is an experiment first kind of platform where we track everything via the experiment or task object. So if you want to get the metrics for an experiment for a model, you have to go through the experiment. But a model store is a model first kind of view where there's a contract, an unwritten contract that there will be tracking data, but the model itself should contain the metadata that you need in production to understand which model is the best or which model should run right now, etc. Of course, all the reproduction and the metadata that you need. So today we're going to see actually how to go from the experiment first to the model first within ClearML, again with as few as lines of code as possible. Let's go straight to the demo. Okay, let's do this. Collab demo. Why Collab? Because I want you to be able to run this immediately. It's even using the demo server instead of ClearML free like I used to. You just take the link, run it, and see for yourself how easy it is to edit the model. When you're starting actually to build upon this, don't forget to change it from demo mode to true, to false, and then you can just use your credentials for ClearML free to have persistent and private experiment data. Anyhow, so let's reconnect and install ClearML. The next thing we'll do is use our famous 2 lines of code for integration. It's slightly more complex here because we're adding the actual URI where to put the actual models in. So if you're using S3 or GCP or Azure Blob, you just put your name here. The credentials and authentication will be done via your config file. In case you just put true, then you'll use the default 100 gigabytes for free that you get in ClearML. Or in the case of the demo server, the demo server file, the demo file server, which will be purged. This is what you need in order to get full experiment tracking, and we can already go to the task itself. Okay, there's nothing here already, but we are in this project, and this is the experiment. And now some boilerplate code. This is PyTorch Lightning, MNIST model with automatic loading of the datasets. Let's run all of it. It doesn't matter right now. Now, one thing that I like to do in order for the demo to be smoother is to go here and go to MNIST and remove Jan LeCun's original file or original server because that's very slow. Anyhow, so we've done this, we've defined everything. Let's do this again, right? We need to do this again. Great. Now, so what do we have here? We have our integration that is slightly deeper than just the tracking. We are now tracking the hyperparameters, both of the model and the trainer. Why like this? Because both Colab and Jupyter Notebooks don't have a CLI or argparse. So the best case to do is just to have some kind of dictionary, and this is completely overridable from the web UI when you're orchestrating your remote experiments, and also very comfortable to see the definitions like this. In this case, we are just doing instantiation of these classes. In the case of the trainer config, I'm using a different max epochs and doing a connect and building the model. We can go to the task now, and you will have these parameters here. See, and they're completely trackable. And all we have to do here is to run this, and yes, okay. Now we are downloading MNIST, and PyTorch Lightning is going to run 5 epochs and train models, right, with checkpoints. Eventually, sometime today. Okay, so what will happen here is that every time PyTorch Lightning is saving a model, ClearML is going to capture this and say, well, this is an actual trackable artifact, and we're going to upload it and give it a name and an ID. So this is what's happening right now. The last one, of course, will be the final model, which we will be most interested at. But sometimes you want maybe to check a different one, and all of them are approachable. Let's just wait until the last epoch is done. I think it's this one, right? Great. Anyhow, so what do we have? We have in the task, we have a registry of all the models that were output. These are the names that PyTorch Lightning gave, and these are the IDs that ClearML gave. And we can just take the last model from the task, and there's already lots of stuff built in. For example, the framework where the model is. There's also some interactive edits you can do. You can add comments freely, and you can even add tags. For example, maybe we want to add a tag of like ready for shadow mode or A/B testing, or example or MNIST, right? So we've already added them. So we can go now, and in the task artifacts, you will see the 5 models, right? And so this model has its own display, and see, we have here the example MNIST and state ready that we just added, and we can go back and track the metrics from there. And now we've added some text, but it's just a text, right? We want actual metadata here. So this is something that you need to insert here. By the way, the labels are already here. So let's add the metadata. This is why we're here for, right? So first of all, the task itself in ClearML has everything you probably need in order to reproduce the experiment. The binary, the diff, entry point requirements, and whatnot. Now, the thing is that you'd like to search over each of those keys, right? Maybe. So what you probably want is a flat dictionary structure for each of those keys. But right now, until I think the next 2 versions of ClearML, you can only have a nested dictionary, but this will do. So let's create a dictionary. It's an empty one, and we'll put the model structure in it. We'll put the model config that we used before, right, and the trainer config, and the dataset that's inside, and also which user created it, the tracking data that I just showed you, also some information on the runtime that we hold, and then we add everything to this giant nested dictionary. Okay, but now we want to attach it to the model, right? What else? Maybe some test metrics, right? Maybe we want to do the test, right, of the model and attach this accuracy and loss to the model. But you can't really edit those because, as I said before, you can edit a comment or a tag. So what's the solution? Luckily, ClearML is slightly opinionated and it knows what you're trying to do. So if you create another output model with a base model ID, it just copies out everything, and then you can add this nested dictionary, change the name. Okay. We can go now and check. There will be a new model here. Let's refresh. There it is. Okay, everything is held in there, all the metadata that you needed, and all that's left is maybe change the name based on the values that's already held in the model, right? So this model already has this config dictionary, and you can just access metrics, valid accuracy, and change the name. And we can go back to the app and refresh it. Oh, we don't even have to refresh it. I love modern technology. Okay, so we have this final model, contains a lot of intricate metadata that as an opinionated SDK we already added. Also the comment that you can freely edit even now. Okay, we can edit from here. And we have this write protected area, right? But now we were in draft mode, so you can again edit from here, which contains, I think it's a whole config structure of all the stuff that we added. This is all the trackable information from ClearML, and the runtime. Actually, we were running on T4s on Colab. That's nice. So all of this information is attached to the model, and of course the labels. Again, the seamless contract between the model and the experiment. If you go to the experiment itself, you can see the metrics of the experiment. Here it's just accuracy and loss. That's what's reported as a boilerplate from PyTorch Lightning. And of course, the thing is that in ClearML, when you have a table for experiments, you have sorting by whatever value that you want. So what I didn't show you, because it's not in this version yet, is the same kind of thing that if you have a flat dictionary structure for models, you can sort by whatever you want. So I would like to sort models by value accuracy, and that's coming. So that's not available right now. Okay, so let's recap. What we've seen is that we've taken very, let's say, standard boilerplate code for MNIST using PyTorch Lightning. We've added to the models that were, of course, saved automatically using ClearML, the costume metadata that we liked, and then we moved the metadata from the experiment to the model, updated the model, and basically that was it. And it was super easy, and I hope you go and try the Collab notebook yourself. Remember, it's on demo mode. You don't even have to register for ClearML. Just go and run it. Good. So next time we'll be on the model store arc. We'll visit the reproducibility aspect and, of course, serving the models. I hope you enjoyed this. Let me know if you didn't. There's comments down below. Don't forget to like us, stars on GitHub, find me on Twitter, retweet my memes and everything. I've been Ariel Biller, and you've been you. Bye-bye.